Today we're going to look at level 3.3, proofs using vocabulary. So we just have a list here, and it's definitely not the only statements or reasons that we can use, but it's a good start for proving triangles congruent here. And just a reminder, keep the definitions and picture examples of the following terms handy to help you as you work through these proofs. And we've got some of our reasons: side, 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 angle, 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 side, hypotenuse, leg, CPCTC, which stands for corresponding parts of congruent triangles are congruent, the reflexive property, vertical angles, definition of perpendicular, right angle theorem, definition of midpoint, perpendicular bisector, segment bisector, angle bisector. So those are just a reminder of some of our words that we can use to get through these proofs here, and then our directions as a good reminder here. Add markings to these figures based on the given information. Consider what theorems, postulates, or definitions apply. Mark the figures accordingly. And we're going to complete proofs 1 through 6 using the bank of statements and reasons provided. We can either use a master bank with all of the statements and reasons for 1 through 6, or we can use a bank broken down by question with distractions. And to make this video here, I'm going to just go through it, but talk to your teacher about getting a bank broken down by question with distractors. But as we take a look here at the bottom of the page, we can see the picture now. We want to prove that triangle CAN is congruent to triangle IAN. And first of all, what we've got is we've got that AN bisects angle CNI. So when we mark up our picture here, that means that this angle and this angle are congruent. And we'll actually, well, that's what happens when that big angle gets bisected by AN. We also know that angle C is congruent to angle I. Those are the two given pieces of information. But one of the words that we saw above here is we saw that we can use the reflexive property. And what we're going to use the reflexive property with is the fact that AN is congruent to itself. AN is in the triangle to the left. AN is in the triangle to the right. And then I was saying it earlier, but we do have, because I said AN bisects angle CNI, then I put the marks in there, and then I wanted to jump to this, so I got a little bit ahead of myself. But angle that CNA is congruent to angle INA because of the angle bisector. So there's the definition of angle bisector. So now what we can say is, we can say that triangle CAN and triangle IAN are congruent because we have two angles and a non-included side. Two angles and a non-included side, two angles and a non-included side. Flipping the paper over to look at proof number 2. We want to prove that segment DN is congruent to segment CN, and we're given some information here. But there's a little bit of an issue on this problem, so let's change this here, and instead of saying that, let's prove that angle D is congruent to angle C. And what we've got in this problem here is we've got given to us that ND is congruent to NC. So we're going to mark that up. We also have that AD is congruent to BC. And then we have a third piece of information here, which is that N is the midpoint of segment AB. That's given. And from that information that N is the midpoint of AB, then what we can also then say is that AN is congruent to BN by definition of midpoint. So we can mark that up. And consequently, what that allows us to do now then is to talk about the two triangles, the triangle to the left and the triangle to the right. And what we can say with regard to that is that we can say that triangle DAN is congruent to triangle CBN. And the reason that we can say that is that we've got three congruent sides, side, side, side. DN is congruent to CN, DA is congruent to CB, AN is congruent to BN. And then once we know that, then we can also say that, and again, we have to switch this up here since we changed that at the beginning, that angle D is congruent to angle C. And the reason that we can say that then is because of corresponding parts of congruent triangles are congruent.